Hello, so here is a review lesson. So this is something we did at the very beginning of the year, so hopefully some of this will sound familiar. So we're talking about radicals today. So I have a couple reminders up here. So when we're trying to simplify radicals, we want to look for perfect squares. So some examples of when I say perfect square, I mean two numbers, or a number that equals two numbers multiplied times each other. So like 1 is 1 times 1, 4 is 2 times 2, 9 is 3 times 3, 16 is 4 times 4, and so on. So if any of these numbers are under a radical, then I know it'll simplify to equal a whole number. So you can read this, but it's mainly just reviewing. So example 1, we got to find the square root. So we got to simplify the square root of 24. So if you remember from at the very beginning of the school year, we had to find two numbers that multiply to equal 24 in this case. So two numbers that multiply to equal 24, there's a few different choices, but I know 6 times 4. Two numbers that multiply to equal 6 are 2 times 3, and then 4 is 2 times 2. Oops. So once you get a pair, circle it, one goes away, the other one comes out. 2 and 3 do not have pairs, so they have to stay inside. One of those 2's came out. 2 times 3 is 6, so your answer will be 2 times radical 6. So in the next example, we have square root of 8. So two numbers that multiply to equal 8 are 4 times 2. I know that 4 is the same thing as 2 times 2. We still have that times 2. So we got a pair of 2's. One goes away, the other one comes out. And there's still a 2 that's left in there because it does not have a twin. So 2 radical 2 would be the answer. Square root of 12. So two numbers that multiply to equal 12 are 4 and 3. You could use 6 and 2 as well. 2 times 2 is 4. Got a pair of 2's, so one goes away, the other one comes out. So 2 root 3 would be the answer. And then square root of 27. So I know that 9 times 3 is 27. 3 times 3 is 9. And we still have that times 3 there. So we got a pair of 3's. One goes away, the other one comes out. So 3, and then we still have a radical 3 in there. Or still have a 3 inside of the radical. Now moving on to example 2. So we got to simplify these bigger numbers. So we do the same thing, except we just got to find factors of bigger numbers. So since this ends in a 5, I know that 5 goes into this number. So if you divide 245 by 5, you should get 49. So I can't break down 5. 5 is a prime number, so I can't factor it. But I can factor 49. 49 is 7 times 7. So now we have a pair of 7's. One 7 goes away, the other one comes out. And there's still a 5 inside, so 7 root 5 would be the answer. Square root of 700. So I know anytime a number ends with 2 zeros, it's divisible by 100. So 7 times 100 is equal to 700. 7 is a prime number, so I cannot factor it. But I can factor 100, and I happen to know that 10 times 10 is 100. So I got a pair of 10's. One of those 10's goes away, the other one comes out. So 10 times root 7 would be your answer. Example 3. So this time we got to simplify. This time we have numbers on the outside. So those numbers will stay on the outside, and then we'll continue to break down what's inside of the radical. So I already did root 12 up here, and I got 2 root 3. So if I break down radical 12, I'm going to get 2 on the outside, 3 on the inside. So now I just multiply the outside number, so negative 3 times 2 would be negative 6, and then radical 3. So this time I have a 10 on the outside. I happen to know that 16 times 16 is 256. So if you don't know that, it's an even number, so you can always just divide it by 2. So you could do 2 times 128, and then keep going until you get all your prime numbers. So we got a pair of 16, so one goes away, the other one comes out. So there's nothing left inside of the square root, so I don't need to draw that radical sign or the square root sign. And I'll just have 10 times 16, which is 160. So just some reminders of some radical rules. We always multiply whole numbers together, and we multiply square roots together. So for example, I got square root of 6 times square root of 8. So another way to write this is square root of 6 times 8. So if they both are under the square root, they can both go under the same one. Now I can do just what we did on the first page. So 6 is 3 times 2, 8 is 4 times 2, and then all these are prime numbers except for the 4, so I can still factor 4. So 3 times 2 times 2 times 2, and then times 2. So I got a pair of 2's, pair of 2's. So one goes away, the other one comes out. One goes away, the other one comes out. So 2 2's are come out. There's only a 3 left on the inside, so 2 times 2 is 4 times square root of 3. So on the next one, remember, keep whole numbers together. So 5 times 3, when we multiply, it does not matter what order we multiply things in. So that's why I'm able to switch the order and put the 2 whole numbers first. And then I have the square root of 5 times the square root of 35, so I could just write them under the same square root. 5 times 3 is 15. So remember, if they're inside, I want to break them down. I don't want to multiply them together because then I'll just have to break them down after I multiply them, so it'll just cause you more work. So I know 5 is a prime number. I can't factor it, but I can factor 35. 35 is 5 times 7. So we got a pair of 5's, so that means one 5 goes away, the other one comes out. So I have 15 times 5 now on the outside, and then on the inside I'm just left with 7. 15 times 5 is 75. Root 7. The example 5, so this time we have something squared. Whenever we have something squared, that means something times itself. So again, I can put the 2 whole numbers first. So 2 times 2, and then square root of 5 times square root of 5, or just square root of 5 times 5. So notice we already have a pair inside of here. So one goes away, the other one comes out. So now I have 2 times 2 times 5. So 2 times 2 is 4, times 5 is 20. So then the next one's going to be pretty much the same thing. So it's something squared, so I can write 4 root 5 times 4 root 5. So 4 times 4 times square root of 5 times 5. Got a pair of 5's, one goes away, the other one comes out. So 4 times 5 will be 80. And then finally the last two. So one important rule to keep in mind, and you might want to write this down here, is you can never leave the radical sign, or this thing, square root sign, on the bottom of a fraction. So we can never have a square root sign in the denominator of a fraction. So another way to write this is the square root of 80 divided by the square root of 25. So that means we're just going to have to break these two things down. I know that the square root of 25 is just 5 because this will be the square root of 5 times 5. So I'll have a pair of 5's, so one goes away, the other one comes out. So now we do not have a radical on the bottom, so that's good. So now we just need to break this down and we'll be done. So I'll do that down here. So square root of 80. I know that 8 times 10 is 80. 4 times 2 is 8. 5 times 2 is 10. 2 times 2 is 4. So, and we still have a 2, a 5, and a 2. So I got a pair of 2's. One goes away, the other one comes out. Another pair of 2's. One goes away, the other one comes out. So 2 2's come out. We still had a 5 on the inside. So our answer will be 4 root 5. So that's what's going to go on the top here, 4 root 5. Then you want to look for, can this number go into this number? So that if they're both whole numbers, can this whole number go into this whole number? And 5 does not go into 4, so we cannot reduce it. So we're just going to leave it like that. So now we have 12 divided by 5 root 6. So we just have a square root on the bottom, so we got to get rid of that. So the way we get rid of square roots is we multiply it times itself. So if I multiply the bottom times the square root of 6, when I have the square root of 6 times the square root of 6, we're going to have a pair of 6's. So that's going to turn into a whole number. So that's how we get rid of the square roots. But I do not want to change this number. I don't want to change the value of this number. So basically, if I multiply by 1, it's not going to change. So if there's a square root of 6 on the bottom here, if I put a square root of 6 on the top, technically I'm multiplying by 1 because this number is 1, because anything divided by itself is 1. So if I multiply 12 times the square root of 6, I'm just going to get 12 root 6. So 12 root 6 divided by 5 times 6 is, and that 5 times 6 is 30. So I'm almost done. Remember on the last one I said that last step we want to check if this denominator, this whole number, can go into, if these two have any common factors. So 12 and 30 are both even numbers, so 2 definitely goes into them. I happen to know that 6 is going to go into both of these numbers. So if I divide both of these by 6, or 6 goes into 12 2 times. The square root does not change. And then 6 goes into 35 times. So if I reduce the fraction, I'd get 2 over 5, and then I still have the root 6 on top.